Hey there, everyone. Welcome to Bursting. People joining, but we're going to get going. We want to start on schedule, obviously. My name is Rob Lalonde. I'm General Manager of the Navops product line here at Univa, where I'm responsible for our cloud offerings. We also have on the line Thomas Francis from UberCloud. He's their head of products, and he's going to talk to you about Ansys workloads in the cloud and doing some real cool containerized stuff in the cloud that UberCloud's doing. And we've got Bill Bryce, our VP products as well, and he's going to give you a demonstration. So off we go. Next slide, please, Bill. I'm mostly going to MC, but I'm going to quickly tell you about Univa before I turn it over to the product experts. So Univa has been in the HPC business for a number of years now. We have offices in Munich, Chicago, and Toronto. We have 250 customers. We really focus on the global 2,000 organizations, so some of the largest, coolest clusters in the world, doing all kinds of neat applications. We'll talk about those in a little bit. We really focus on scale. We've got customers running 7 million jobs a day. We have clusters that are in the order of 300,000 cores, and we sit on top of about 2.7 million of our customers' cores, so that number's gone up a little bit. Moving on to the next slide. I'll just tell you a little bit about our customers. We're really strong in life sciences, where we have 10 of the top 12 of the largest life sciences companies in the world. We have about 32 airlines, I think it is now, changing every week it seems. We've got a lot of the large manufacturers in the automotive and the racing space, and you can see a lot of electronics companies as well as oil and gas and government and financial services. So those are just a sampling of the logos, and the applications, of course, are things like genomics and molecular modeling in life sciences. It's fraud detection and machine learning in financial services. It's oil and gas exploration type applications like seismic exploration and pipeline analysis over on the energy side of our customer base. So those are just some of the cool things our customers do with our workload management solution. Moving on. The product line breaks out into two fairly distinct sets, but they're very integrated and related. So on the left-hand side, we have our Grid Engine product line, which focuses on workload management and scheduling. And on the right-hand side, you see our Navops product line, which is all about our cloud strategy, both hybrid cloud, dedicated cloud, and our cloud-native capabilities as well. If I just drop down into a little more detail on those. Next slide, please. You can see on the high-performance computing side, we've spent a lot of time moving Grid Engine forward. Some people might know Grid Engine from even the Sun Microsystems days. It's not your grandfather's Grid Engine. It's a very modernized REST APIs for high performance. We have a Unisight monitoring and analytics tool that rides alongside Grid Engine. We also have license orchestration capabilities. And then on the right-hand side is our Navops product line, which extends Grid Engine to the cloud. So we have capabilities to do hybrid and dedicated clouds with our Navops Launch product. That's what we're going to talk about today. We have our Navops Command product, which is orchestration and multi-tenancy for Kubernetes. So if you're doing cloud-native applications, Command's a great offering to take you to the next level there. And then lastly, but not least, we have our URB product, which allows you to run Mesos frameworks on top of both Kubernetes clusters and Grid Engine clusters. Now today we're going to focus really on Grid Engine and Navops Launch and bursting those workloads to the cloud, and then talking about how Ansys runs on top of that hybrid infrastructure and burstable as well, and that's what Thomas and Bill will talk to you about. Next slide. So we've seen a big shift in our customer base over the last couple of years. 5 years ago, no one was doing cloud. 2 years ago, there were a handful, just a couple. All of a sudden now, we're seeing 61% of our customers, this is from a very recent survey, 61% of our customers are open to going to cloud or are already actually in the cloud with our products. So a really massive shift, and I think HPC's time in the cloud has come. People are really starting to move in that direction. Of the customers that are transitioning to cloud now, we see 70% of those going to hybrid, and about a third, about 30% actually going to dedicated cloud. So there is a mix of configuration options with the Navops Launch product, and sort of that addresses the customer's needs to either go hybrid or dedicated. And in many cases, they're actually doing both. Maybe starting with dedicated in a departmental cluster or a specific application, going to hybrid for their entire HPC cluster, and then still running some dedicated niche applications in different corners of the business as well. So that's pretty interesting, and that's a real driver for this webinar and for talking to you about these solutions, because there's just a ton of demand and a ton of interest, and poor Bill on the line can barely keep up with our customers right now and all the activity with them on the cloud. Next slide. So I'm going to turn it over to Thomas now. Welcome, Thomas, and thanks for joining us today. I'll pass it over to you to tell us a little bit about UberCloud and your solutions.
Great, thanks, Rob. In the last slide, we saw that interest in cloud is booming in the HPC space. But I want to just wind the clock back a little bit, back to 2012, which is when UberCloud was founded. So back then, cloud was already mainstream in many areas. So Salesforce.com, which is the canonical SaaS software as a service vendor, was 13 years old in 2012. And AWS had been around for a while. So cloud was already well understood, but not in the technical computing and HPC space. So we realized that cloud adoption was lagging quite a bit in HPC, and clearly there were some barriers back then. And so we set about trying to identify what those barriers are, what the challenges are that customers are dealing with that were preventing them from adopting the cloud in greater numbers. And the way we did this is by what we called experiments. Experiments were short projects. They're typically about a month long, a completely voluntary effort where we just brought together a hardware vendor, typically a cloud provider, a software vendor, Ansys being an example, but there were others, and an end user. And we put them together in a project team and helped them work on a real-world problem to identify some of these issues. And then at the end of the project, we'd have them write a case study that was published for the community to download and read through. And just to give you an idea of how far we've come, the first set of experiments, there was each experiment took about 3 months on average, and there was over a 50% failure rate. So over 50% of the experiments failed to reach their stated objectives. Now, in this last set of experiments, we've continued to do these experiments, by the way, every year. And in the last set of experiments, each experiment took less than a week, and we had a 100% success rate. So there's been a lot of evolution in this space in the last 6 years. If you would like to see what some of these challenges were back in the day and how we solved them, feel free to go to our website and you can download some of these case studies there in the resources section. So based on some of these learnings, we decided to build HPC containers starting in 2013, and we had our first set of containers in 2015. And in the meantime, we'd signed partnerships with various software vendors, including Ansys, and our partnership with Univa actually goes back all the way to November of 2015. And in 2015, we released our CAE software containers. We had one for Ansys. These are, for example, available in the Azure Marketplace, so you can go and actually launch them from there. I'll talk in detail about what these containers are and why they're helpful in this space. But just to kind of bring us up to the present day, in 2018, we've deepened our partnership with Univa. So UberCloud is now a Univa reseller. And we've also become an Ansys Advanced Solution Partner this year. This is the highest level of technology partnerships with Ansys. Next slide, please. So we talked about these software containers that we've developed. So let me just give a short primer on what containers are, what we're talking about here, and then I'll talk about what UberCloud has done with containers. So the metaphor is a shipping container. So prior to a shipping container, there was no standardization. So if you wanted to ship something from Shanghai to San Francisco or back from San Francisco to Shanghai, there wasn't any guarantee that when your products reach the other end that there's going to be a crane capable of picking them up or a freight train capable of transporting them. There was really no standardization before the advent of the shipping container. But once you got this standard shape and size and weight, you could do a lot of things because you knew that at the other end there was going to be a crane that was capable of picking it up and transporting it, etc. Similarly, in the case of a hybrid world where you don't have any guarantees on where your application needs to run on, standardization becomes very, very important. And containers are a type of virtualization technology. They're based on some core features of the Linux kernel. How are containers different from virtual machines? Well, virtual machines virtualize hardware, as we all know. So, for example, VMware can take one CPU and make it look like 4 CPUs or 6 CPUs and share them. Containers operate at a level higher than virtual machines. So, containers can virtualize the operating system kernel. And this makes them very lightweight because they're not carrying around a whole operating system wherever they go. And it also makes them very portable. So VMs can be portable as well. VMs can move, for example, with VMware can move a virtual machine using vMotion. But there's some pretty restricted use cases there because you need to have vSphere on both ends, etc. Containers are anywhere there's a Linux operating system and a Docker runtime, containers can ostensibly run on. So it makes them very suitable for a heterogeneous infrastructure. So think of an example of a hybrid cloud scenario. Bill mentioned that there's tons of interest in hybrid cloud. So in hybrid cloud, you have an on-premise HPC system potentially. You got some cloud going on, maybe even some workstations, and containers are a very good way to run the same application in all of these different places. And Docker is really the most common container standard. There are others, but UberCloud is built on the Docker standard. Next slide, please. So containers are an incredibly popular technology for microservices. They've really swept the world of microservices. Microservices are a design pattern for web-facing applications, but containers are not exclusively to microservices. They can be used to run regular legacy applications, and that's what UberCloud has done. We've taken this this technology platform called containers, and we've adapted it for HPC workloads, so that HPC users get all the benefits that containers promise. So we've enhanced it for running engineering and scientific application software, such as Ansys. And so our containers have all the tools and capabilities that an engineer would need. So for example, they would have an up-to-date version of the operating system, MPI libraries that are required for running parallel workloads, any utilities you need for remote visualization, for example, data storage needs, NFS shared storage, etc. And finally, the engineering application itself. And the application includes things like the licensing, etc. So this is and as I mentioned, when we did the experiments, we kind of made a list of all the challenges that were preventing people from adopting cloud in greater numbers, and you can see how some of these challenges are being addressed with the notion of the container. So from our standpoint, the container is designed to deliver all the tools that an engineer needs in order to run their high-performance computing, computer-aided engineering workload without needing to install any software, without needing to deal with complex operating system commands or configurations, etc. Next slide, please. Okay, so now that we know what containers are and how UberCloud uses containerization to make Ansys available in a heterogeneous hybrid cloud infrastructure, why does all of this matter? What's the real benefit or the advantage to say an Ansys user or to a HPC administrator who's whose users are users of Ansys. Well, at a high level, what containers let us do is offer HPC performance with a desktop look and feel. So you get the parallel computing capabilities that a true HPC system would allow you to do, but at the same time, you get the simplicity and ease of use of a workstation. And this is important because it really widens the possibilities. So you don't have to have an on-premise HPC infrastructure to leverage some of these tools. You could be running on a workstation for your day job, and when you need HPC performance, you can burst out to the cloud using Univa Grid Engine, and the look and feel and the user experience is very similar to your workstation. It's not requiring you to learn anything new. So let's go through some of these points here. First of all, is a hybrid infrastructure. Rob talked about how hybrid cloud is really the most popular incarnation of cloud. And it makes a lot of sense because customers don't want to just switch from one mode to another. They want to have a little bit of both because there are use cases where the on-premise is superior and there are use cases where the cloud is better. So you want to have the ability to switch back and forth based on your specific needs. Well, containers let you run your Ansys workload on-premise and in the cloud. And there's a lot more to it than just picking up the container and moving it to a different location and running it. And we'll talk about some of those. So with the hybrid infrastructure, you get all the benefits of cloud, including this ability to scale up and down. That all of that is only possible when you have the licensing and all of that stuff worked out behind the scenes in order to enable that scaling. So for example, in the case of Ansys, there's elastic licensing, which is required to scale things up and down. In addition to that, the second point here around the GUI capabilities, Ansys has some very sophisticated graphical user interface tools. As I mentioned, if you're coming from the workstation world, this is what you do day in and day out. You're not really, you don't really use Ansys in any other way other than starting up Workbench and using a drag and drop approach. And Workbench is a sophisticated tool that lets you set up complex multiphysics simulations using a simple drag and drop approach. So you can pick up structures and drag it onto the canvas and pick up a fluids module and drag it onto the canvas, link the two up and do a complicated fluid structure interaction problem. Well, you can have that same kind of workstation-like capability with HPC infrastructure in the back end using containers. So if you're an Ansys user, you don't have to learn a new unfamiliar access model in order to use the cloud. You can use the same familiar workstation-like interface running in the cloud with all the great capabilities that the cloud brings you as well. UberCloud lets you run Ansys through a web browser in the cloud, so you get maximum ease of use. And the other big advantage of having a strong graphical capability for interactive analysis in the cloud is that you can do pre and post processing in the cloud as well. So it really minimizes that data transfer back and forth. This is one of the things that users come to recognize in this heterogeneous infrastructure is that when you're moving things around between on-premise and off-premise, there's a lot of data that needs to go along with that. And so you want to do whatever you can to minimize that data transfer. And one way to minimize that is to do as much work as you can in the cloud. So you can do your pre-processing, you can post-process your results and minimize that data transfer because of this GUI capability that's available. You can also access it through SSH command line from your workstation for additional interactive analysis. And batch users also have a batch interface. This is enabled through an integration between UberCloud, Univa, and CycleCloud from Microsoft. So Microsoft provides the HPC hardware in this case. CycleCloud creates HPC clusters using that, and Univa orchestrates UberCloud containers onto this hybrid infrastructure. So some of this this integration is still underway. Please get in touch to find out how we can support your specific use case. And I mentioned the elastic licensing at the end. I'll just finish up with this. Ansys has innovated in this space, and it's actually been available for 2 years now, elastic licensing. And what you can do is you can buy a pool of elastic units, and as your workload needs it, those licenses get consumed. And these can be mixed up with paid-up licenses, etc. So in a hybrid scenario that we've talked about, you can have your perpetual license for the on-premise cluster, and you could use the elastic licensing for any overflow to the cloud. So I think I'll stop here. I just wanted to give you a flavor of what's possible today in the cloud. And if you'd like to discuss your specific use case and how you can benefit from some of these tools, please get in touch with us. Back to you, Rob.
Yeah, that's fantastic. Thanks, Thomas. We look forward to working with you more and more. We've been doing some really great things, but as I said earlier, all those manufacturing customers and EDA customers are on the move, and I think your solution with containers is doing great things to make it a lot easier for people to move to the cloud. So having said that, I'm going to turn it over to Bill now, who's going to talk about Navops Launch, which is our cloud migration solution, and how that works sort of hand in hand with the UberCloud offering to move containerized applications to the cloud. So Bill?
Okay, so first I'm going to describe what is Navops Launch to give you some background in the overall technology, really to tell a story and give you an idea of how people would use the system in conjunction with Univa Grid Engine and also with UberCloud's containers. So Navops Launch is a critical piece because what you have to do is you have to dynamically create nodes in the cloud and then attach those nodes to your existing infrastructure, the networking infrastructure, the domain naming system, the identity management, and then also connect them, of course, finally to the Grid Engine cluster so it can actually run work on those. And what we did is we created a tool to do this really out of necessity because ourselves, we run things in the cloud. We run a lot of our own testing and regression of Univa Grid Engine in a public cloud environment. So Navops Launch came out of that. And what you can use it for, as you can see from the slide, is to create different kinds of clusters, typically technical computing or HPC clusters, but a mixture of physical nodes, virtual, or cloud. But really, most people use cloud today. They don't typically use it for physical. And the system can automate the configuration management of the nodes. But it can do it under policy control. So you can create rules which decide when the work does burst or when, in your cloud cluster, when it expands and contracts based on the needs of the work arriving in the Grid Engine environment. And we've integrated with all the major providers of cloud services. So Amazon, Azure, Google, any OpenStack, Oracle. We could do VMware as well. So you're not really locked into any one particular environment. And then that last point there on the slide on the right, the integrating well into existing brownfield environments, this was really important for us because we know that when you are adding this cloud infrastructure to your existing environment, it has to behave well and integrate with the way you do things today. And that's what Navops Launch can do. So I mentioned that policy-based cloud bursting, and this is really the important part where you can go into a tool. In this particular example I'm going to show you today, it will be Unisite, and create rules. And those rules use metric data from the cluster. So it knows, Unisite knows about everything that's going on in a Grid Engine cluster or one or more Grid Engine clusters. And then you can use those metrics to make decisions because the way Grid Engine behaves typically is you have configured it to represent how you run your work in a day-to-day environment. So, you put jobs into particular queues, you attach particular resources to those jobs, and the system, the scheduler, knows where to put them in the environment to run them efficiently. That's the whole idea. And so using that data and using the rules, you can make actions happen in the cloud environment, like add nodes, delete nodes, that type of thing. And really the goal of all this is to create that seamless hybrid cloud. And, you know, it really is a progression. Most people don't, you know, start from the beginning, I have my on-premise cluster, and then immediately go to the seamless hybrid cloud environment, because it's a pretty big step. There are a lot of decisions that have to be made along the way, and you have to test things out to make sure it's appropriate for your particular workload. Because an important thing to understand is that the workflow or the way you run your workload on-premise is different than when you run it in the cloud environment, because you know, things do have to change. You do have to decide how you're going to move your data from on-prem to the cloud infrastructure. You can see here over on the right, some sort of system has to be decided upon to do this. It could be as simple as just an rsync, which is very trivial, or as complex as choosing something like a LASTA file, which is a system that can do this transparently, syncing between the on-prem storage and the cloud storage for you. You also have to decide on your networking configuration, you know, for the cloud provider. That has to be set up so that there are, you know, dedicated connections between your on-premise environment and that cloud environment. It has to be set up, configured, secured with, you know, VPNs and VPCs, for example, if you're using Amazon EC2, and firewall security groups. And you have to have something like Navops Launch, which is already integrated in with the cloud provider APIs, to talk to the cloud provider to ask it to go and create resources on your behalf. And when you have that environment, then taking your traditional batch or machine learning, your analytic workloads, and containerized and non-containerized workloads can be done. Now, the containerized is probably the simplest of all, because really, once it's in that container, as Thomas mentioned, it can be moved from on-prem to that cloud environment much easier than copying directories, copying files, and things like that. But this seamless hybrid cloud is the goal. That's where many of our customers want to go. But as I mentioned, they start typically with trying it out first on the cloud and then extending to the hybrid cloud. So I'm going to give you some case studies. These are actual customers who have gone through this process. And the first one was Wharton. So Wharton is a school globally known for its intellectual leadership and innovation in business. And they do technical computing work. They have an HPC cluster, which is on-premise. And some of the researchers came to the team that ran the cluster and said, we need GPUs. Well, interestingly, they used to have GPUs in their cluster, but they were actually decommissioned. They were getting too old. And so at this point in time, they went through a process to decide, you know, does it make sense to purchase new machines with GPUs, or will it be better to go to a cloud provider and ask them, you know, what's the cost, you know, and crunch the numbers and figure out does it make sense to use the cloud-based GPU nodes, because frankly, they don't need them all the time. They need them for a particular amount of time. So they did this. And what they came up with was, it made sense in this particular customer's case to go to Amazon EC2 and use their GPU instances at that time. But he also realized that he needed something to make it more transparent for Grid Engine to extend to this cloud environment. And that's where we presented Navops Launch to them. So Navops Launch provided that seamless bursting to public cloud for GPUs and applications like TensorFlow that the Wharton team was running. And a really interesting thing happened. Well, first of all, they started off using a few GPUs. They did their economic model, and they realized that, you know, using a few GPUs, using them effectively, and understanding the whole economic model, which is, you know, the usage of the amount of money Amazon is charging them for using it, the fact that Amazon is updating those nodes over time, and that they provide a level of service that they didn't typically have before. When they crunched all that together, it turned out to be a pretty good deal. Pretty similar to what you would do on-premise, but with the advantage that Amazon is always updating their infrastructure. But another thing that happened was that once people began to use it, they actually began to using it more. And so they started off with a small footprint in the cloud and ended up transparently tripling their core count in the cloud for their researchers and scientists to use with Univa Grid Engine. So that was a significant cost avoided. I mean, they didn't have to go, buy new infrastructure, stick it on a truck, put it in a building, use electricity, cool it the whole bit, and give them a lot more flexibility. But another really interesting thing it gave them was that, as I mentioned before, Navops Launch works with all the major cloud providers, so they can actually go out there and look at other cloud providers, such as Google or Microsoft, and see, do they provide a better value proposition? Is the economic model even better with, say, Google for their GPUs than Amazon EC2? So they weren't locked in. They could choose which one worked best for them. Now, this is a similar type of case study for hybrid cloud bursting, but in a different space. And it's important because you can see that there's a progression from where you would expect, people who are more academic community are willing to try things out. They have a lot more flexibility in how they can configure their infrastructure. Would that translate to someone in a different vertical, like EDA, as an example? Well, it turns out it does. And we see a lot of these smaller to medium-sized EDA organizations are adopting cloud very rapidly. And one of them, as you can see here, is Mellanox, and they did this with Microsoft Azure. And again, it's very similar in concept. They don't want to go out and buy a whole new set of hardware, have a new building, wired up, electricity, cooling, the whole bit. They didn't want to do that because really they had massive resource bottlenecks during tape-out. And tape-out in the EDA world is like crunch time. This is when, all hands on deck. We have to make sure everything we're doing for the chip design is ready to go, it's tested properly. All sorts of things can go wrong. And they need quite a lot of compute resource to get this done, usually within a very strict timeline, because it comes down to money. For example, if you were a chip manufacturer and you're trying to create a new chip that goes into, say, the next iPhone, and Apple says you better deliver it in June. If you don't deliver in June, you miss the window, and you don't get that entire cycle. This is the type of situation they get into with EDA. And so to avoid that, they need massive amounts of temporarily large resource. So they used Azure for this. And again, Univa Grid Engine is highly integrated into their workflow, so using Navops Launch made sense to scale out in that hybrid environment so that the nodes could be added dynamically to the Mellanox cluster and then run the workload. And so you can see it was, I don't have to mention the customer value. It's pretty straightforward. They're only using it when they need it on those expensive tape-out times. Now I'm going to show you a short demonstration of I'm going to talk a little bit about Navops Launch, give you some idea of what the tools are, tell you where we're going, because it is an evolving thing and it's rapidly changing. And I'm going to show you a demonstration of, running all in the cloud. It's not a full hybrid cloud because that environment is more complex to set up for this type of demo, but we have done it, as you can see from the previous two case studies. So let me switch over. And first of all, I'll start with things that you're familiar with. If you've used Grid Engine before, you are probably familiar with command line. So I realize this is not the prettiest way to present the demonstration, a good place to start, but really most of this stuff is wrapped by the team managing the cluster so that the end users don't see it. So what we have here is a very simple Grid Engine cluster with one node, and that one node is in Amazon EC2. Navops Launch is a tool that allows us to manage it. We can figure out what the node status is. And Navops Launch has a system of profiles that allow you to define, what type of node is this? You can see here I've got an Ansys exec-D node, which is really a P node. It's not like your normal Grid Engine execution node. I have a Unisite node, which is running the system that controls the rules and drives the automation. And I have the installer node, which is this system that does Navops Launch. So I can actually add other nodes. I could do it manually. I'll just show you how to do that. And what that did is there was a lot of configuration behind the scenes, obviously, to do that single command, and sent off a request to Amazon to go and create a node for me. And because things are asynchronous in this cloud world, it takes a little while for the action to happen. It happens in the background. Like I could have fired off 20. This is one of the nice things, actually one of the key things about Navops launch that people really like is I could launch 20 of one type of node and 15 of another type of node, and they all go off and it asynchronously starts to build that environment and assemble it into a cluster. So you'll see that from an automation point of view, behind the scenes, it's off adding the node, wiring it up to Grid Engine. Now I'll switch over to Unisight to give you some idea of what's going on with this system. So I think it briefly was mentioned a couple of times in the presentation what Unisight is. It's really reporting and monitoring. So you can connect it up to any Grid Engine cluster, and in this one in particular, it's connected up to my cluster here in Amazon EC2. If I needed another one, I just add another one, put in the appropriate information, and it connects up to more than one. There is a dashboard over here and sort of a simple heat map which shows you which nodes are up and running and ready to go. The one I have prepared, which is the big beefy one, it's ready to go. It's got 31 gig. I think it has 8 processors. This is a good node for Ansys. And you can see the other nodes are not quite up and ready to go yet. I won't go into a lot of detail, but if I had jobs in the system, they would show up here. And then you have the basic idea of utilization of your cluster, what's going on in the cluster queues, the job state by count, the efficiency of the cluster, things like that. There's a lot of other things you could do with Unisight, but it's much beyond the scope of this particular demonstration. Really, I think you're probably more interested in this, which is the rules. So rules are very straightforward. You create a rule name, which is like my test rule. You give it conditions, and as I mentioned, this is the nice part, which is, okay, so I have probably different types of jobs waiting in my Grid Engine cluster, and I want to make a decision on that. So I will look at, like, say, job name. And if job name equals, Bill, and let's see, the job, here's it, this project shares the host object. Job state is queued wait. That means my jobs are waiting and they're not running. Then do something. And typically I'll take like the job ID and I'll stick it into a variable. And then I perform an action on it. And this is where it gets interesting. You could have it, execute another rule, so you can chain rules together and make complicated actions. You could execute an external command, or you can just display it on the screen. A very common rule that people create is show me all the hosts that are in a bad state. So rules are really, really generic. You can do all sorts of things. And then it can have options, which show you whether it's a polling rule, event rule, if it's enabled, disabled, how long it polls, that kind of thing. And then the test didn't find anything. So that's not a great rule. I've got some in here which are more interesting. This one looks for jobs that are in the queued wait, and they have a job burst resource assigned to them. Then again, it gets the job slots out of the job. And it displays the information on the screen and goes and calls a script, which is remote add, and passes the job slots to it. So that remote add script goes and talks to Navops Launch and adds new nodes. And then this is how it's a polling rule, so it polls every 100 seconds. And again, there's no matching. So that one adds them. And this one finds idle nodes and gets rid of them. So if the host has no jobs on it, and in this case, I set it as for the Linux type hosts, then get the host name and call a script to delete it. And in this case, it matched one, but it's not going to delete it because it's my special node. So even though it matched, it won't delete it because the script is smarter than that. All right. Now I want to actually show you the UberCloud container running. So let me do that. It's quite a long Q subline, which is why I'm using the history. So let's do that here. All right. I'll tell you a little bit. I don't know if you can see this. It's big. I'll explain it. Even though it is long, as I mentioned before, you typically wouldn't have users do this. You would have it wrapped, so it's much easier to use. This is a Q sub command to Grid Engine, and you're telling Docker, you're passing parameters to Docker. That's what this XD means. You're telling it to run a privileged container with the network configuration of host. You're going to give it the name Ansys test job. You're going to tell it to run on a Docker, a machine that has Docker installed on it, and has the Docker images Ansys 19 CentOS 7. Then you set a bunch of environment variables so we can connect to it, including license server. And let's submit it. So it's already running. And actually, I don't think Thomas explained this, but what happens is once you run it, you notice in here I have my customer email configured. It sends me an email immediately telling me how to use the container. So I'll switch over. I apologize, I'm going to go to my email so you can, there we are. And my super secret password, which everybody gets a randomized one. And we will log in to this container, which has been created for us. But that looks like Ansys. And this is actually the container running in Amazon EC2. And as you can see, it's got the tools here, Ansys workbenches here. Just fire it up. Takes a little while. Now, getting your files in and out of here, no, I'm not willing to participate. So you've got Ansys up and running. You'd have different options. You would either set up a shared file system between your on-premise environment and your cloud environment and then mount that into the container. You'd use something like Dropbox that exchange files back and forth a little more easily, things like that. That's already set up within the container, as you see. So, I mean, you're ready to go. You can, run your project, do your work. And you can see that it is running. More. Now, the reason I didn't do the automatic bursting in this demonstration is purely for time reasons, because it can take a while to set up the instance and then get the container up and running. So I did prepare, but using those rules I demonstrated, you can actually add and remove nodes automatically to the cluster on demand based on your needs. And then when you're done, you can shut it back down. So you can see there is another node here. So if I submitted even other jobs to the system, they would go to those other nodes. And in fact, if we sat here long enough and waited, this node here would delete because it's not actually running any work, even though we added the cluster. In fact, we could probably get it to do that if we force the system to trigger. Look for idle jobs there. Nope, it didn't find any. So let's see, check what the conditions are. Post job count is 0. All right, that means they're running too many jobs. Oh, that's why. Let me double check. Anyway, I think that's good enough a demonstration for now. So you get